All right, AP Environmental Science. This is our second day of working on our research project for cemetery demography. So I just want to make sure that you filled in this data table. Okay. If you haven't gotten this part done yet, then pause the video. Okay, you need to go back and finish up your research because you can't go on unless this part is done. Okay, so this is my data. I went ahead and I did the project myself, just like you guys did. And this took me, half hour, 45 minutes to do the research. Went on the cemetery database and just collected data at random. All right, so if you have that done, all right, now you're ready to move on. Now, in the Buzz agenda today, I do have a link to my data, and you may want to use that a little bit later on. And there's a reason why you're going to probably need to use my data. So just keep in mind that there is a link there on the Buzz agenda. But again, all we did here was we had our four cohort groups, right? We had males before 1950, females who died before 1950, then males and females after. So you should have a total of 15 individuals for each cohort group. Now, when we're studying, populations, one of the things about data is the larger the sampling, the more accurate it's going to be. So even though, we spent a half hour, 45 minutes, maybe an hour doing this research, we really only collected a very small sample of human beings in this country who died, before 1950 or after 1950. I mean, 15 from each is not really that many individuals. So the accuracy of our data probably isn't going to be all that great, but hopefully it will be okay. But what we're going to do to kind of make it a little bit more accurate is we're going to take our own data that we collected. So you have your own individual sheet. The other kids in class have their own individual sheets that look something like this. But I want you to combine it with another classmate. Now, you can use me as your classmate if you want to. Okay, if you're at home virtually, I'm going to be your classmate. But if you're sitting in class and you would rather work, with a friend and maybe share some information, now, I suggest you may not want to like trade papers. Maybe take a picture of each other's data, and that way you can use it because you're going to combine it with yours. So we're going to double the size of our data because I think it'll be more accurate, right? The more people we have, the more individuals we have, the better. In years past, I mean, we would actually combine an entire class, worth of data. But this year's a little bit different, with the COVID and everything. So we're just going to kind of minimize it and just kind of combine your data with another classmate. So what you're going to do today, at least the first part of class, we have a 90-minute class today, um, is on this second or on this next page. I believe this is page 4 of your packet. This is the group data. This is the combined data. So all of the numbers on here are your individual data plus one other person's. So, for example, you would take your data and my data, combine them together. So, for example, let's say here we have the males before 1950, right? So, going back up here, we kind of flip back and forth here. So, here's our males who died before 1950. So, all we're going to do is we're just going to look at each age group, like 0 to 9, 10 to 19, 20 to 29. We're going to count how many individuals died in that age group. So, for example, like 0 to 9, just kind of looking at my first column here, it's kind of going down, going down, going down. There's one. So I see one individual, all right, that I have. Now you'll notice, in this chart, I put the number 4 there. Well, that's because I combined my data with another individual's. Okay, so this number 4 is the number of individuals who died between the ages of 0 and 9, not only from my chart that I collect, but also with my partners. Okay, so you're going to do that for all of these age groups. Okay, again, these numbers don't represent your data, they're your data and your partner's data. All right, so we should get a pretty good sample size that way. We're basically doubling our data. So we're going to work on that today initially. All right, that might take you maybe 15 minutes, maybe a half an hour to get this chart completely filled in. All right, so this is our combined data. Now, once you have that done, then you're ready to move into these data tables. All right, now this is where it can be a little tricky, so I want to make sure that, again, you have this chart completely filled in before we start this part. All right, so that's like kind of crucial. So make sure that we have that other chart filled in. All right, so if you look at this data table, there's one, two, three, there's 5 columns that you're going to have to fill in. And you'll also notice in your packet that there are 4 data tables, all right, because each one of them is for a different cohort group. So, for example, this first one is for males who died before 1950. So if we go back to our second chart up here, all right, so we're going to use all of these numbers here. This is all of our males who died before 1950. We're going to use that data to fill in this chart. All right, so in fact, this first column right here, all right, this where it says the number of deaths in class, all right, that is basically just copied from that previous chart. So we had 4 people who died between the ages of 0 and 9. We had 2 between 10 and 19. We're just copying that column right from our previous data table, okay? Now this column, each one of these, you'll notice that there's like this variable here, like D sub X, L sub X, etc. That comes in handy for some of the things down here. So for example, you'll notice right here where it says the total number sampled. This is the sum of the D sub X column. So that's basically just add up all these numbers. Okay, if you add them all up, you'll get 30. And you should get 30, right? Because you combined your 15 individuals with another 15 individuals. So you should get this number. This number should be the same on all 4 of your charts. All right, these other numbers are going to change. But this first one, it should be the same. All right, so let's go to the second column. Okay, this is the number surviving from birth. All right, this is known as the L sub X column. Now, you'll notice that the first number that I put in here is the number 30. All right, because what that basically means is that before we get into this age group, there are 30 individuals that are born into it, right? Now, not all of them are going to survive to come out of that age group, right? But 30 of them entered that age group. Now, we know that from this column over here, that 4 individuals died between the ages of 0 and 9. So essentially, 30 individuals came into that age group, 4 individuals died. So that means going into the 10 to 19 age group, there are 26 individuals, right? 2 of them died. So going into the 20 to 29 age group, there's 24 individuals. Do you see how I did that? Okay, so as you go down, these numbers are getting lower and lower and lower because more people are dying as you go into some of those age groups. All right, so that column will need to be filled out. Now, those numbers, again, will vary between all 4 of your charts, right? All 4 of your cohort groups are not going to be the same numbers. All right, so going over to the third column, this is called the survivorship per 1,000. Essentially, what we're going to be doing in this column is we're going to be converting these numbers out of 1,000. So, for example, let's say that there was, instead of 30 individuals entering the 0 to 9 age group, let's say that there was 1,000 individuals entering the 0 to 9 age group. Okay, so we want to figure out how many of those 1,000 would actually survive to go into the 10 to 19-year-old age group. So all you're going to do for this column here, all right, is you're going to take the number of individuals, in this case 26, divide it by 30, and then times it by 1,000. So if you take 26 divided by 30, times that by 1,000, you're going to get 867. Okay. If you go down to the next number, you take 24 divided by 30, times it by 1,000, and you'll get 800. So you're going to do that for each number. 18 divided by 30 times 1,000, you get 600. All right, on and on and on. Okay, so that's where those numbers are coming from. So you're going to need a scientific calculator, to figure out those calculations. And again, those numbers should decrease as you go down. All right, and eventually you're not going to have any individuals left. Right, that should probably make sense. Now this fourth column, this is really easy. All you're going to do is on your calculator, your scientific calculators, you're going to find your log button, which is right there. You see it there, LOG. All right, find your log button, and all you're going to do is take the log of your survivorship. So, for example, this number 3 here, okay, just in your calculators, hit LOG 1,000 equals, and it should be 3. Log of 867 should be 2.94. Log of 800 should be 2.90. So again, those numbers are decreasing as we go down as well. All right, now the last column, all right, this one's a little tricky, but if you just kind of pay attention to this formula here, it's kind of simple. It's LX1 plus LX2 divided by 2. So here's the LX column over here, that second column. So all you're going to do to find this number here, we're going to go over. Okay, this is our LX1. We're going to add to it the number below it. That's our LX2. So 30 plus 26 divided by 2, and you get 28. Okay, you go down here to the next number, and you're going to go over 26. This is our LX1. Add 24. That's our LX2. Divide it by 2, and that gives you 25. Go down to the next number. Go over 24 plus the number below it, divide it by 2, gives you 21. Okay, so you'll do that all the way down here. Okay, so those are the columns, and you're going to do this for every one of your data tables. The numbers will all be different. Okay, and they'll be different from your partners too. Okay, unless, well, actually no, they'll be the same because you and your partner actually combine your data, so they should actually be the same. Now going down here, okay, there's 2 other things I want you to figure out. This first number here where it says total years, says the sum of the mean alive. That's what this last column is. So you simply just add up all those numbers. Okay, and that in this case you get 151.5. That number will vary from group to group, from chart to chart. Now the last thing, which I think is kind of interesting, is the life expectancy. So we're going to figure out what the life expectancy is of this particular cohort group. So to figure that out, you take the sum of the mean alive, which in this case is 151.5. You're going to times it by 10, and then you're going to divide it by the number sampled, which in this case happens to be 30. In this case, you get 50.5 years. So this cohort group of the data that we collected, these are males who died before 1950, their life expectancy was 50.5 years. Now, is this the actual life expectancy of all people who died before 1950? Probably not. But we're going to use this number to compare it to our other 3 groups. For example, the next chart you're going to do is whatever females who died before 1950. So you can kind of look and see what the life expectancy was of males versus females. Then we'll do these 2 charts for males and females who died after 1950, and we'll be able to compare life expectancy. So I think it's kind of safe to say that life expectancy of people who died after 1950 is probably going to be a little bit higher. At least it should be, right? I mean, hypothetically, it should be. But again, these sample data that we took was kind of random, so we'll see how accurate it comes out to. All right, so once you're finished with that, then those four charts. The last thing that you have to do is to graph your survivorship curves. So when we graph our survivorship curves, I don't have a picture of that with me here. Let's see if I can bring that up real quick for you. I want to show you this real quick. Let's see, cemetery lab. Okay, so here we go. So this graph here, you'll notice the axes. Okay, you've got your log 10 column. That's your survivorship column. Your log 10, and then you have your age. So these are your cohorts. Right? This is the 0 to 9 age cohort, the 10 to 20 cohort, the 20 to 30 cohort, etc. Okay. So all we're going to do is we're just going to plot points. So on these charts, what you need to basically do is these last two columns, those are the axes. Okay. So for example, I don't know, I don't have my, oh yeah, I do. It's over here. So like, for example, the 0 to 9 age group, right? The log 10 was 3. So we're going to go down here. Whoops. We're going to find 3, right? So there'll be a point there. And this is the 0 to 9 age group. So we're going to put a point like right there, right? So you're just going to plop these points. Now, I think it's safe to say again that, you know, we are humans, we are K species. So our survivorship curve should probably look something like this, right? So it's going to kind of tail off at the end, right? If we were an R species, it would like, drop off at the beginning, right? So you're going to plot two different curves on this first graph. All right, this is going to be your males who died before 1950 and your males who died after 1950. So you're going to have two curves here. Use two different colors. You'll make a little key that shows me which one is which, and then you'll do the same thing with the females. Okay. So I'm going to give you guys the rest of the day today. You've got the weekend to get this done. I mean, this is kind of a daunting task, but maybe we break it down. Maybe do a little bit of it today, a little bit of it tomorrow. My kids in class have got 90 minutes today, so they could probably get a really good chunk of this done if they work diligently. All right, so if you have any questions, feel free to email me. Have a good day. This is due on Monday, by the way.